Example 9, Chapter 6. Consider the simple steam power plant as shown in the following picture, and the data also are available as the table. At first, the leaving boiler point, this point, entering turbine, the point 2, leaving turbine, this point, and leaving condenser, this point, and leaving pump also is this point. For the boiler pump work also available as this quantity. Determine the following quantities per kilogram flowing through the units. Determine A. Heat transfer in the line between boiler and turbine. In the line between boiler and turbine, this line. B. To find out the work. C. Heat transfer in the condenser. Heat transfer in the boiler. So we start with A, heat transfer in the line between boiler at point A. The energy equation is Q plus HI, which we can write H1, V1 and Z1 for R. It is same to 0, so Q is H2 minus H1. H1 is at temperature equals to leaving boiler megapascal table A B3 superheated. You can check with your book. And H2 and a little decrease in AN superheated. and equals to, you can also check the book. So q dot equals to the difference of two non-clear. The part 2 is calculate the turbine work. The turbine work, we should use the data for point 2, which is centigrade. We also extracted the H for point 2 and H at point 2 calculated is extracted from B3. Point 2, point 3, we have the information about point 2 in the problem now. P equals 2 and quality is 90%. So for table B2, E1, 2 for the P, 50 kilopascal. H is HF plus X HFG, which is equals to, you can check with the tables from your books for the quantities. H3 can be calculated and is for turbines. We can write the with this case from H2 for the unit for mass. W control value. The turbine in the past give us the Q equals to 0, the difference between velocities, and W is calculated as H2 minus H3. H2 is H3. We have an output for kilojoule on kilogram. Part C, heat transfer in the condenser. We should use the information about point 3. Consider this picture. Point 3 for the condenser and point 4 is 2 points in the picture. Point 3 we have just calculated the enthalpy H3 is kilojoule on kilogram. Point 4, we have this information about point 4. Pressure is 14 kilopascal and temperature is 25 degrees centigrade. You should check with the tables. Okay. H4, consider this table. In this table we should first check temperature 25 degrees. P saturate is 5, P4 is 40 kilopascal greater than, so our H equals to saturated liquid HF and is kilojoule on kilogram. The condenser Q equals to H2 minus H4 minus H3. Can be also obtained from H4 plus G4 Z4 W equals to 0, Q equals to, for the unit mass we have this relation, H4 minus H2 H3 leave the control value. And the last one is heat transfer in the boiler. Boiler, we should consider point 5 and point 1. Consider the next page for the picture of the cycle, the diagram of the cycle. The boiler should be consider the point 1 and point 5. To calculate the point 5, we have point 4 information, H equals to and temperature, pressure. For pump we have work rate as our now, which is 4 kilojoule on kilogram. So to calculate the information for point 5, we should write the energy equation for pump. The first law for pump, there is no heat transfer, Q equals to 0, H4, and the velocities are approximately same. Equals to H3 plus W, H5 plus W. W pump, H5 H4 minus W pump. W is input work, so the W pump is minus 4 kilojoule on kilograms. So H5 is kilojoule on kilogram. To calculate the heat transfer from boiler, from the first law, Q is the heat transfer plus H5, same velocity and altitude, H4 and 0 volt. So Q boiler, H4, H1, H1 minus H5. H1 is obtained as superheated previous minus kilojoule on kilogram. This is the end of this